This is the new Prusa CORE One L. Not that much bigger on the outside than its little brother, but with twice the print volume. I was finally able to test it here in the studio, so in today's video, I want to talk about how it performs and whether they managed to fix some of the things that annoyed me on the old CORE One. So, is the CORE One L not only the bigger, but also the better CORE One? Let's find out more. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. This video is sponsored by PCBWay. Just 3 weeks ago, a few creators and members of the press were invited to an impressive reveal event in Prague, where Prusa basically shrunk us all down and put us into their new large volume machine. You can find more details about the event in my last video. Unfortunately, the test machines took a bit longer to arrive than expected, but I was stoked when the CORE One L finally showed up in the studio, because it comes with some really nice new upgrades. The CORE One L currently sells for €16.99 or $17.99 fully assembled, and there's a link in the description that also supports the channel. There's no kit version right now, and probably won't be for the foreseeable future, because they switched from a 24-volt bed to a mains AC bed, and they probably don't want their customers to fiddle around with that. Unboxing the machine was straightforward, and I love how they print the unboxing steps right onto the pieces of cardboard to make everything as smooth as possible. After installing the screen, removing a bit of foam and adding the spool holder, it was ready to be turned on. Setup is done using the LCD screen. That is arguably not the prettiest, but finally also a touchscreen. You can, but don't have to connect the machine to your network and to Prusa's cloud service, Prusa Connect, which I'll talk about later. The build chamber camera now finally also comes with the machine and can, but doesn't have to be installed. It's a completely separate device that only takes power from the printer. If you want to use it, the machine needs to be connected to the cloud service. The setup is cleverly done using the Prusa app and shows a QR code that you scan with the camera to connect it to Wi-Fi and to your account. Once that's done, you're ready to go. The machine doesn't need to be pre-calibrated because the bed is probed anyways before every print. Phase stepping, which reduces motor noise, is pre-tuned at the factory, and the input shaper values are preset, so no resonance sweep is done before each print. The printhead PCB now finally has an accelerometer on it, so you can, if you want to, do phase stepping and input shaper calibration yourself without needing to buy an additional accessory as on the smaller CORE One. The whole unboxing process takes around 10 minutes and was really straightforward. And since the machine weighs only, in parentheses, 22 kilograms, this can easily be done alone, something I really struggled with on other machines. The weight is actually even slightly less than a regular CORE One, because they switched some of the panels from steel sheet to aluminum, so magnetic accessories will still stick in the usual places. I started my last review by saying that the CORE One is finally the printer I'm not embarrassed anymore to show my friends. And it's the same with the CORE One L. I really like the outer appearance. The sturdy black frame, the bevels, the slightly tinted windows, and the colored accent of the handle and the LED bar under the bed. It just looks different from the flood of wannabe X1 carbon clones on the market. Sure, the build isn't as clean and polished as a Bambu Lab machine, but it has this steampunk post-Soviet vibe I actually kind of enjoy. When I visited the Prusa factory 3 weeks ago, I understood where that came from. The whole place looks like a scene straight from Half-Life 2, and the CORE One would fit perfectly into Dr. Kleiner's lab. Almost everything looks as if it is made with the tools that they had at hand. Bent sheet metal, 3D printed parts, pieces of acrylic, zip ties, dangling wires, and an interface that's functional, though not necessarily pretty. Don't take this as a criticism. I seriously love the look, but some might prefer the clean Apple-like design other manufacturers go for. Anyway, enough of a tangent. If you, by the way, need professionally made parts at a competitive price, you should definitely check out PCBWay, who sponsored this part of the video. PCBWay not only makes amazing circuit boards for your projects and products, but they're also great at making anything else. I've regularly used them when we needed prototypes for upcoming products. You simply upload your design, select a material, provide some details if necessary, and directly get a quote. Within just a few days, they manufacture and deliver everything, so you don't lose any time. They don't just do CNC machining, but also sheet metal fabrication, injection molding, and 3D printing, even metal printing in titanium. If you're curious, check them out using the link below and see how inexpensive it is to have them make professional parts for you, from one prototype up to full serial production. Thanks to PCBWay for sponsoring this video. The specs of the machine are pretty much the same as the old Core One, besides the double print volume, now with a print area of 300 by 300 mm and a height of 320 mm. The outer dimensions only grew by around 10%, and if you put both machines side by side, they don't look massively different. The heat bed, a thick sheet of milled aluminum, offers a very even, though not necessarily perfectly on point temperature. It goes up to 120 degrees Celsius and doubles as an active chamber heater with additional fans. The inside air is recirculated over the bottom of the bed, making the chamber heat up faster than with simple passive convection. This way, the chamber reaches up to 60 degrees Celsius, which is great for technical materials. On the other hand, the hot end tops out at 290 degrees Celsius, enough for most materials, but with new high-temperature nylons and polymers like PPS becoming more affordable, being able to go just a bit higher would have been nice. The Core One L comes with two nozzles, a brass high-flow nozzle and a standard flow hardened steel one. Though, honestly, I don't understand why they don't just include a high-flow hardened steel nozzle right from the start, so you never have to swap. The spring steel sheet that comes with the machine is their satin PEI variant, which works well with most material and gives prints a nice, consistent bottom texture. It's a good all-rounder, but if you mainly print PLA, definitely get their smooth PEI sheet too. PLA just sticks way more reliably on that. The new plates also do have a QR code in the front that the camera can detect at some point in the future, probably informing you in the slicer if your sheet and material are compatible. I've ruined more than one PEI sheet in the past by printing TPU or PC blend on it. Other than that, you get a linear rail on the x-axis and guide rods on the y-axis. The Prusa MMU3 will also be available early next year for the Core One L, though honestly it's still a messier and more complicated system than what many other competitors offer today. I had several major annoyances with the regular Core One that I hope that they finally fixed. Let's start with print quality, which wasn't bad, but if you compared it directly to other machines, you could notice a slight surface pattern. Prusa addressed that so-called VFA issue by changing belt tension and adding some slicer trickery, which noticeably reduced the ripple effect. Most of my prints on the Core One L looked good, and if you don't have any direct comparison, you'd probably be happy. Only in edge cases or when the printer slows down for cooling do the VFAs start showing again, for example on the blower hull of the 3D Banshee. But if you stick to the standard balance profile, even parts printed in silk PLA now look way better than the ones I initially got on the Core One. Let's look at some prints. This water dragon in PLA looks beautiful. Tons of details and crisp definition. Then there's Gollum in marble PLA, which of course hides small defects, but still turned out great. Though I definitely wouldn't want to bump into that bust at night. It gets more interesting with Clock Spring's Torture Toaster. At first glance, the print looks perfectly respectable. Everything moves, tolerances are free down to 0.2 mm, and the overhangs look good as well. But if you hold it up to a light, you start noticing some strange surface inconsistencies again on those smooth curved surfaces. And once you see them, you can't unsee them. It's the same with the Prusa Puppy or even their own sliced rocket engine. Without a comparison, you probably wouldn't notice. But it's there. Interestingly, these artifacts seem to coincide with the strange speed changes you can see in Prusa Slicer when you enable the actual speed visualization, which factors in acceleration, jerk, and junction deviation. I tried a few things to debug this and couldn't get rid of it completely, either in the speed preview or in the actual prints. The only improvement I found was lowering the external perimeter speed to around 70 millimeters a second. Then the print movements looked smoother and the VFAs were basically invisible, making the appearance of the print so much nicer. Yes, in the case of the Torcho Toaster, this adds around 30 minutes to a 5.5 hour print, but I'd be happy to have a print profile that prints a bit slower, but gives me those really smooth surfaces. At that point, I stopped debugging because I want to review the machine as it is, not as it could be. This should be a tool, not a project. When we already talk about printing speed, yes, the Core One L can print fast and is as fast as the small Core One. And the profiles are set up in a way that they more or less match what Bambu Lab does. If it should print that fast is another question though. Back to the prints. The 3D Benchy was printed in 40 minutes using the normal speed profile, and overall it looked good and clean. I only have two complaints. First, you can still see a bit of those VFAs on the bottom, where the material prints shinier because it was moving slower. VFAs are speed dependent, and there are certain speeds where they're more pronounced. Normally, you'd set the perimeter speed to one where surface quality is the best, but when the printer slows down for cooling, you hit those bad speeds again. The second complaint is the small gaps visible on the upper surfaces, when the pressure advance value is, in my opinion, set too high. Unlike, for example, Bambu Lab, there's no automatic filament calibration on Prusa printers. The pressure advanced values are almost hard-coded into the filament profiles. So if the results don't look optimal, you have to test and set them yourself. But Prusa Slicer doesn't include a way to generate these test patterns, so you have to use Orca Slicer for that. Why? I sometimes don't understand their stubbornness in thinking good enough is enough. This starts with proper pressure advance calibration, especially for a high-speed printer. Sure, their default values work fine most of the time, but sometimes you have that one filament that behaves differently. Orca Slicer became so popular for a reason. It includes the calibration tests people actually want to do out of the box. So Prusa, please make life easier for the rest of us. And this isn't the only stubborn thing that gets me mad. On the old Core One, I regularly got nozzle cleaning errors with certain materials. It happened all the time. I'd start a print, leave the room, and later find out that the print paused because the nozzle cleaning routine failed. To their credit, they added an ignore button. And they also changed the filament loading routine, and that helped a lot, but it still happened twice during testing the new machine. I wouldn't be that frustrated if this were just an unavoidable problem when nozzle probing, but it isn't. This has been solved for years. Basically, every other printer these days comes with a nozzle wiper, which would fix so much of this frustration. If you sell a professional machine, make sure things like this just works. And that every time. Good enough isn't good enough just because you don't want to copy the competition. I actually loved when I unboxed the machine and saw that they now also secure the print bed with a few screws highlighted in red, something I first saw on Bambu Labs machines. I seriously wonder how many internal debates they had before finally biting the bullet and doing this as well. Sometimes you don't need to reinvent the wheel, just take inspiration from works and improve it, and they did. The little red tags they use are way nicer than stickers that you can barely peel off. Anyway, enough of a rant, sorry for that. I had some seriously frustrating hours while making this review. Don't get me wrong, there are things that aren't perfect on the Core One L, but honestly, which machine is? We need to look at both the good and the bad things to give an informed opinion. First of all, Prusa listened and they fixed the annoying top vent. It's now automatically actuated by a flexible lever on the top of the print head. Depending on whether you're printing PLA or PETG, where you want a cool environment, or sometimes like ASA, where you want it hot inside, the printer will automatically open and close the vent during startup. It's not as flashy as the automatic vents on the Bambu Lab machines, but it's super simple, and with fewer moving parts, there's way less things that can break. The top panel can now also finally be removed without destroying the rivets. Fantastic for maintenance. What I don't understand, though, is why they didn't add a Pokayoke feature, so it can only be installed in one orientation. Right now, you can install it however you like, and if it's possible, someone will install it the wrong way around. This will render the top vent useless, resulting in poorer print quality and leaving users frustrated and confused. But something often overlooked on enclosed machines is the filament path. where the PTFE tubes rub on the top cover and have tight bands near the extruder, making filament feeding harder, increasing drag, and sometimes breaking brittle filament. The CORE One L handles this nicely. There's enough space on the top to avoid rubbing, and the filament is guided into the extruder in a big radius. On that note, another small useful addition is a switch at the first filament sensor to disengage it, letting you easily feed flexible filaments into the extruder. And that works really well. The only problem is that there's a second sensor at the extruder itself, where the filament then gets stuck. And this even with Prusa's own 95A shore hardness material. So you still have to remove the Bowden tube and push the material through. If they solved it for the first sensor, why not add a similar feature on the print head as well? Still, once the filament is in, even soft TPUs print beautifully. When printing, the noise level is quite acceptable. It's not as silent as the old Mark III, but this one prints roughly 3 times faster nowadays. So with great speed comes slightly more noise. When in idle, it's completely silent. The fans only spin when needed. During PLA printing, I measured around 50 to 55 dBA with peaks up to 60 dBA during travel moves. Closing the door reduces noise a little, but since the housing isn't airtight and has top vents, the effect is small. I wouldn't want to sleep next to it, but it's fine to have it running in the workshop. It only gets loud when the chamber fans kick in. Especially if you use something like my DIY HEPA and charcoal filter for the CORE One that has a lot of flow resistance. But if you don't use such a filter, the fans are barely noticeable. Speaking of air filtration, the CORE One doesn't include an air filter by default and simply exhausts the air out of the bag. I'm a sucker for clean air, so I added my own DIY solution when the original CORE One came out. But for a while now, you can also get Prusa's advanced air filtration system made in collaboration with Alveo 3D. It's a beefy HEPA and charcoal filter rated for about 600 hours of printing, plus an additional radial fan that mounts to the bag and is controlled by the printer. This is, in my opinion, an excellent upgrade. It filters the barely noticeable yet still unhealthy fumes and particles from PLA or PETG and almost completely removes the smell of PC or ABS. It also creates a slight negative pressure inside the chamber so that air doesn't leak out through all of the gaps. I mean, sure, people also choose to smoke, but if you're spending long hours in the same room as your printer, this is a must-have upgrade. That said, I have to add that the internal temperatures are higher with the filter. That didn't cause printing problems in my 20-degree studio, but could cause issues during summer. Another upgrade I had completely overlooked for a while is Prusa Connect, Prusa's cloud-based 3D printing management platform. It's completely optional. You can still send print shops over your local network or, very old school, carry your G-code on the included USB stick. But with Prusa Connect you can send and monitor prints from anywhere, with tons of useful statistics and even print farm management features. And this doesn't only apply to the browser version. The Prusa app on your smartphone also works great. If only the app wouldn't nag me every time I start a print, telling me that the printer needs personal assistance, even though it's already happily started printing. Other than that, I'm impressed. I thought only Bamboo had a flawless cloud and app experience. But after using this for a year, I have to say Prusa Connect is definitely on par. And if you manage several printers, it's even better. A feature also worth mentioning is Prusa's EasyPrint, their online slicer. It lets you slice models straight from printables right in your browser without installing any software. That might be not something for the power user, but it's perfect for family members who just want to hit print without touching Prusa slicer. Seriously, give it a try. What's unfortunately still missing though is the implementation of Prusa's new OpenPrintTag system, which they announced the same day as the CORE One L. OpenPrintTag is an RFID tag for filament spools that stores data like color, material type, and remaining filament. So you never load the wrong spool again and wonder why your prints failed. And this isn't a way to lock you deeper into the Prusa ecosystem. OpenPrintTag is completely open, and Prusa actively encourages other filament and printer manufacturers to adopt it. In the future, no matter whose filament you load, your printer will automatically recognize the material and color, streamlining the whole workflow. All of the documentation is already out there, but Prusa won't have it fully integrated in their printers or slicer until sometime next year. And that also means that the Core One L also doesn't have an RFID reader yet. That's all a bit of a pity, because it's a genuinely great idea. So far, the new Prusa CORE One L has been working really well for me. I think it looks beautiful, minimalist but unique, and while a few areas still need polish, the overall experience is solid. The prints look good, yet not perfect, but I'm sure Prusa will keep tuning the profiles. The slicer, printer and materials all play very nicely together. So, is the Core One L the better Core One? Yes, it definitely is, mainly because of the quality of life improvements and a better heated bed. I hope we see some of these changes in a Core One S overhaul someday, or maybe they will simply include the improvements in the newer Core Ones that are built. But if you look at the competition, it's hard to ignore that you can get a Bambu Lab H2S, including their multi-material system, for less than what the Core One L costs without one. That competitor has more features and a slightly better print quality. So who should buy this machine? In the end, a lot boils down to idealism. You buy a Prusa because it's manufactured in the European Union, or these days also directly in the USA. You buy a Prusa because they don't force you into a cloud. They even offer a critical infrastructure edition for medical or military customers that completely removes networking, with G-code transfers only via encrypted USB drives. They let you use any slicer you like. Their own slicer, which they open source, is the foundation for almost any good slicer out there today. They build machines that are easily repairable. Many parts are themselves 3D printed, and anything else can be ordered directly from their store. And when something goes wrong, they have real people in support chat who actually try to make things right. Western manufacturing, proper support, and the lack of heavy subsidies naturally make these machines more expensive. That's just a fact. But it's still impressive that Prusa remains one of the last Western companies producing consumer and prosumer 3D printers at a kind of reasonable price. And honestly, we should be proud of that and also support it. So if you're not chasing the absolute best bang for your buck machine, but instead want something that delivers solid quality, is backed by excellent long-term support and will likely be upgradable when the next version arrives, the Prusa CORE One L and the ecosystem around it will probably not disappoint you. If I was able to help you in your purchasing decision, consider using the links down in the description. They help me keep the lights on here in the studio. Thanks for watching, everyone. I hope you found this video interesting. If you want to support my work, head over to Patreon or become a YouTube member. Also, check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye.